Right, I'm back from doing that, so let's have a look at what we've taken out. So 470, I think we put 35 volts in everything. Seems to be a bit low ESR. Well, there you go. That one isn't working. So that would have helped the audio, wouldn't it? Okay, low battery. Here's one I prepared earlier. Right, well that's supposed to be 220, and this one that looks like it's been changed at some point. Yeah, they've all seen better days. Right, connect it up. Got the factory original mic with this. I want to use a standard replacement. That isn't on this bench at the moment, so in view of that we'll use the one that's come with it, because I won't set the deviation up with this. Right, switch on. And we'll start by testing that it works in public address. I'm just going to start it at 9 volts at 300 milliamps current limiting, just in case there's something wrong. And we're lit up. Pop it to channel 20, go to 13.8 volts. It's drawing the current I'd expect it to draw. We'll go to PA. And unlike the smaller model, you can actually control the volume on the PA. Testing 1, 2. Well, you can if it works. Testing 1, 2. 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 1, 2, 1, 2, 1, 2, 1. Right, so some Wally had forgotten to solder the capacitor in one of those. You probably saw it high in the air, whereas I didn't from here. So, there you go. That's sorted. So that's PA working. I need to get a sheet and we'll go through some of the parameters. Right, here we are. So we'll go into the low scale. So we're looking at 3 watts is full scale deflection. We're still in PA, that helps, doesn't it? In fact, I'm still plugged into. I'll just change tack here. Just did the deviation. Had another look at that with the Giessen marine CB we were doing. So I'll just do the deviation check on the test set behind me while we're still plugged into that, and then we're done with it. So I'll check it and correct it if necessary, all in one operation. So let's get ourselves, it's that one. So I won't touch it, but we'll put the tool in there ready. Wow. Yeah, it's 1.8, so that wants to come up. Wall. There we go. Oh, just make sure mic gain's full, because no, it wasn't. Just recheck that. Wall. It didn't affect the deviation very much. It had gone to 2.7 as a peak. Right, so that's done that. I won't switch that machine off, because behind the scenes I'll probably test it with a standard replacement mic. So back to where we were. So it was 1.8 and it's now 2.2 to 2.5 kilohertz. So here we go. Let's see what we've got. Just beyond full scale deflection, it's 3 watts dead on. I seem to have got tools under my piece of paper. Have I migrated slightly? Three watts. And 2.9 watts. And 3 watts. Back to channel 20. We're drawing, wow, we're drawing 750 milliamps. That's efficient. Won't be when we've got 4 watts out of it. And on low power, it's doing 250 milliwatts. So if we've got a realistic service manual here, we'll get on with the we'll get on with the VCO. I don't think it needs doing, but just for completeness. Using the TRC 2000 manual, done on channel 40. Only need to check transmit, and as ever, I can't remember whether these are a ground chassis or whether it's a floating chassis. Let's see. All over the place, so it needs to have an earth. Where's all the crocodile clip leads gone? I keep going across with other things. Oh, here's the yellow one. Put it on that coil can as an earth. Somebody said there's a nasty hiss on the sound, so we use 4 Shure SM58 microphones splayed around in front of me. They're very expensive microphones. They go into a preamplifier and then into the Vision mixer. They have to go in the preamp because for some bizarre reason the Vision mixer doesn't take ordinary microphones. So we could go out and buy one of those £19.99 great big microphones that look impressive, and it would probably work better but with worse fidelity. I think the hiss is when we have the ultrasonic cleaning running 2 rooms away on the air test. I'm usually cleaning records in the evening. But there you go, it could be done, or we could change the solid state microphone preamplifier for a valve one, couldn't we? Especially if somebody sends me about 140 quid to do that. We could build a valve preamp I'd need even more money that way. So the test is test point 1. I hope I brought my glasses back from the chapel. I did. My more powerful ones. So test point 1 is the resistor. Can't ever remember. Wait till you get into your 60s. Right. So it's the TRC 1000 is the equivalent model. See what test point 2 is. And test point 1 is resistor 52. Okay, in transmit we should have 3.5 volts. Let's make sure that's in the screen. It's going to transmit. It's 3.7. I'm not going to adjust it for that. And I'm going to check on channel 1, even though it doesn't tell you to. I'm satisfied that's in lock. They then want you to do this coil with an oscilloscope connected to test point 3. Now, you don't need to do that at this stage. That's when you've got to, if you built this brand new, you might need to do that to get it to start receiving. But because it's already working as a working set, we don't need to adjust that, and we'll do it with the synod meter later on. So that was 3.7. So that's satisfactory. Had it been 3.8, I might have adjusted it, but it's never been fiddled with. You can see it hasn't. But it's test point 1, once again, is that resistor which has no insulation on it. You've got the 2 capacitors there, the resistor there. So that's that done. Alright, we'll go through the transmitter and check we've still got picture in picture on. We have. So on channel 20, before we do this, we'll just see where we are with this meter. Hello. That's high, low power. That's high. So this is supposed to be in the centre of the red zone. So because it isn't calibrated, for want of a better word, I'll just put low. I'll do the receiver in a bit. We're going to just check the frequency. It's not non-adjustable on this set, and the test set has been on now about 20 minutes. So let's see how we go with that. So we're looking for 27.79125. 27.79107. It will rise as everything warms up. As I say, it's non-adjustable. It's just a matter of changing the crystal if it drops out of what's an acceptable limit. And we wouldn't worry if it was anything under 086. You start changing crystals at 07 something. It becomes illegal like 026. So there's a long way to go before it's off frequency. So 27.79106. So that's that done. So back to the main meter. Let's see if we can get 4 watts out of it. Can't on all, but usually got a fighting chance with these. So what we're looking for is the centre of the peak, not just the peak, and that's so that it's balanced across the 40 channels. I think this is transmit on these, it is. Again, I could refer to the realistic 2000 manual. Look, I spent £16.99 on that, wasn't it, in 1981. They knew how to charge, but, you know, all these years later, how many people have got that? I had all those manuals on for free use on that Scribed website, and then they tried to charge me to look at my own stuff, so I took everything off. Spot on 4. I may have to drop that down because the set's warmed up. I mean, these aren't nasty, cheap sets, but at the end of the day, it transmits 5% duty cycle. And as you warm up the transmitter, it's going to drop in power. So I'll come back to that at the end, but not necessarily on the video. Now, I don't like that. It's 3.6 on channel 40. And that's interesting. Let's just have a look at this again before we start looking at the movement of... So that's 3.9 on channel 40. 3.5 on channel 40. I'm just looking up to make sure we're actually at 13.8 volts. We are. I'm just going to look at placement of these. It's very important how they're placed. It's also important, I was talking about smoothness. You know, coming out like that, it's going around a right angle. It isn't ideal, but that's how it's manufactured. Oh, just make sure the placement of these coils is spot on, because to be honest, that one looks slightly out. That looks spot on. So we're at 4 watts on channel 20, which is how we left it. I'll just check channel 40 again. There's only 3 on channel 40. And 3.2 on 1. So that's 4 on channel 1. See where this anomaly is. Got 4 there. That's channel 20. And that's 4. "40" is 4. 1 is 3.5. So I've got 3.9 on 1, 4 on 40 and 4 on 4. Right, I think that's the best compromise. Right, I mean that looked pretty close to where it should be, and then it wasn't. So back on channel 20, current consumption is now 968 milliamps. Low power is now what? It's now dropped to 160 milliamps. Let's just tidy those up. I hate them to shift in transit. And I think that's our low power. Yep. And there we have it. 400 milliwatts. So that's that. Let's look at the RF meter now. Oh, on high power. So it's more towards the centre of the red zone now. So I'll just move it a little tiny bit further to the centre of the red zone. And there we're on the centre of the red zone. So that's that. Right, we'll move on to the receiver. So now we'll put the synod meter into the extension speaker socket. Make sure RF gain's at full. It wasn't. Make sure squelch is down. And that we're in a socket that says extension speaker. So I can hear that, but you may not be able to. I've got S9 signal running in, 100 microvolts. And let's go over to the synod meter. Check what frequency we're putting into the signal generator from the signal generator, 79128. So we'll just turn that down slightly because the radio is not quite at the specified frequency. So I want to tune it on the frequency it's at. 90108. There we go. Right, here goes. You can end up with it lopsided. So what's the news? So for 12 dB, these are never as sensitive as Cybernet sets. They're loved more because they're better for bleed over, but a lot of the bleed over is caused by silly people transmitting on loads of channels or with illegal high power and all that malarkey, so it's not always the set's fault. It's not brilliant at all, is it, that? No, Mr. Tango, it's not brilliant at all. In fact, it's rubbish. Absolutely abysmal. So it is 1.9 microvolts, nearly as deaf as a Cobra 29. No, not quite as deaf. 10 dB, 1.5, and for 20 it will do it, it's 3. Squelch. It's a full squelch. Let's see what we need to open that. It is 2.6 millivolts, which is too tight. and the threshold is a not very good 2. Needs to really be under 1.4. Right, let's see whether we can do better. Could do better. I bet my report said that. You know what? If I'm not interested in a subject, I'm not gonna. I got something like 7% in my French exam. Didn't want to do French anyway, so I'm never going out of the country. Why do I want to learn French for? Well, that's no better. That's no better. This is why this set's immaculate, because it's never worked properly. Well, that's the front end done, and it's still as deaf as a post. Let's look at the detector. I usually do that first. We'll go to the oscilloscope. So the detector is going to be that one. Very minutely out, but that doesn't affect the sensitivity like that. Now we'll look at these. Back to the cyanide meter. Look at the IFs. That one looks out. Just check this one, which we're supposed to have checked. So at the moment we're at 1 microvolt for 12.85 for 10, and I've gone and just knocked it off frequency like a wally. I'll just put the signal generator back on frequency and down a bit because it's slightly out. That'll do. Let's go over this again. Once again, I'm going to check the detector. You know what? I think we're going to change some capacitors in this receiver. Although it's just in spec, I think. Let's just have a look what the spec says. I'm just used to really, really good sets. Oh, yeah, we're actually well in. We're supposed to do 0.5 for 10 dB, and it's at the moment doing 0.7. So the limit spec's 1 microvolt for 10 dB. So I can be used to the Tabernet sets, which are better sensitivity. I don't think it makes any difference, you know, because the noise floor is such that you're never going to be receiving like 0.2 microvolts like you're going to get on a Binatone 5-star. What have we got? I'm back to this. I just think we can probably just get something quite easily better. I can hardly see these. It's too small for me. It's supposed to be an A3 printout, but we've got some capacitors here in this between the stages, and I just feel that if I change some of these in the front end, we may get some better results. So that's what I'm going to do. I'll go back to chapel and we'll spend a bit more of the customer's money. Right, 5 capacitors later, and we'll see whether we're any better off. Might help if it's connected to power. Well, I can't see any change, but we'll go through it again. I'll just check that detector just in case, because there was one around there that I did. No change there. I think we've got a change there. Okay, for 12 dB, we have 1 microvolt. For 10 dB, we have 0.85. For 20 dB, we have 2.2. Squelch now. Oh, shall we do the RF meter? Yeah, we'll do the RF meter. S meter. So, what we got? 5. So at the moment, to read S9, you need 180 microvolts. Not stupidly out. So we'll just twiddle that. So with 100 microvolts on the test set, signal meter, it's now S9, and the squelch, the squelch to full. And now I'll go to the attenuator so you can see what I'm doing. So we want, at 100 microvolts, which is on right now, we should have an open squelch. I'll just change the speaker to one you can actually hear, just in case you can't hear that one. People can hear my ultrasonic cleaner, but they can't hear the radio. Right, here goes, squelch. Right, well, it's not going to do that. So what's the best it will do? 170 microvolts. Well, that's an awful lot better than where it was. There's no hard and fast rule on this. It's my decision that it's S9 is what we want to be able to just squelch out. Turn the volume down, and sensitivity. Set threshold. Switch the signal generator back on. Oh, that's awful. That's 3 microvolts. That's as bad as it was. Let's just see whether I can set it more carefully, or whether it's the radio. Yeah, it's 0.95. And I've just thought of another thing about the sensitivity. I've got the tone in the high position where it's got more noise. So I'm going to go back to the cyanide meter and just show you that, because we should really be doing it in the low. Oh, no, it was in the low. So that I did it the right way around. No, that's fine. Forget that. Forget I came. So the switches all work. What about the potentiometers? Let's go back to the PA so we can hear the mic gain. Testing 1 2, testing 1 2, 1 2, 1 2, 1 2. That's fine. Squelch we've already checked, and RF gain we'll go back to. Fine. They don't need any intervention. So we'll see how that goes on Scratchy Corner. So we didn't gain much with the capacitors. You know, it was not worth spending another, well, half an hour in total, and probably £3 worth of parts. So back to what the manual says. So they'd like it to be 0.5. The limit is 1. It's at 10 dB, and our 10 dB on this one is 0.85. So we've got, for 12 dB, we've got there 1. So it's not ideal, but it's well within the limit spec, and that's what we're here to make sure it does. So yeah, squelch, they want it to be 1,000. Well, I don't. I want it to be like 100. But that, you know, this is it. This is what it's about. This is experience. Right, there we are. I think we are all done. And we'll button it back up. But it's quite possible that this... Oh, I'll just check the power again, because now it's cooled down, it may be very different. It's 4.1, so it's not too scary. Right. Yeah, it's quite possible that this didn't work very satisfactorily, because the IF was quite a bit out. And being as deaf as that was, at 1.9 microvolt, he's well out of spec. So I just think it's kind of got shoved on one side. I mean, I knew somebody who got the Audioline 340, the smaller one. It's the same kind of circuit, but it's a different board. And they hated it. They bought it mail order, they returned it. But in actual fact, it probably just needed to be realigned. But of course, they shouldn't need realigning. They should do when they're brand new. But it's how it is with these things. Nothing changes apart from the ones with no alignment. Right. Yeah, we'll button this up and just make sure the speaker is working. I am daft checking the polarity, you know, but I'm going to check the polarity. Not that one. It's that one. So that one is our negative. This is only relevant if you're doing things with stereo. So I'm just behind the scenes. I'm going to be checking the radio with a standard replacement mic, and I'll just recheck the deviation. Yes, I am putting the screws back, but I'm not going to put any more back now. I've thought that I need to do that. Well, not on that half anyway. Let's do this half. Because they're a bit bassy, the factory original mics. Quite unliked. Those replacement mics that we get seem to be quite a lot more crisp. There we go. Just pause the video while I do that. Right, I've just done that, that's alright. Just check with the walkie-talkie. Put it on channel 20. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. Fine. Right, we'll put it on the aerial and see what the channels are full of. I think the answer to that will be nothing. It's 2:30 in the afternoon on a Friday. it on its own speaker. 1 on a Roger. $19 a Roger. Bit of distance something. Right, we'll do an on the air test on that. So there we are, really swish looking Audioline 341. Thanks for watching.